Okay, class, in this video, this is the beginning of chapter 13. We're moving into trig. So this is kind of new territory for some of us. You might have had some exposure in the past in regards to this topic, but we are going to spend 2 chapters in this course on trig. This first part is just getting us familiar with the basic ratio of trigonometry for right triangles. So what is trig? Trig is basically comparing sides in a right triangle and the ratio of those sides. So that's what trig is basically. So basically I'm going to go through several different examples, and a lot of this, you might refer to SOHCAHTOA, and feel free to use that if you want to. Again, I'm just going to go through the different patterns, and again, this is something that you're going to have to, learn or memorize. So choose how you want to understand this material. Some use SOHCAHTOA. I like just to use examples and get used to the patterns, but it's something that you're going to want to know very well and get very good at. First thing we want to do is let's take a look at our calculator. So let's go ahead and turn it on, and let me turn it on here. And the first thing you want to do is hit the mode button. And in this case, where's my mode? Or actually, mode's up here. Okay, so hit the mode button right next to the second key. And these are all different modes for the calculator. We want to scroll down to this third line, which says radians and degrees. So I'm going to scroll down, and we want to be in degrees. We'll get to radians later on, but for this first example, we're going to deal with degrees, and we'll talk about the difference later on. So I'm going to hit enter. I'm now in degree mode, second quit. So first thing you want to do is make sure your calculator, otherwise everything's going to be thrown off. You have to tell the calculator what to do. Okay, let's take a look here at a couple examples. Now, notice we have 2 different pictures here. Trig is based on the relationship of sides based on the angle that you're looking at. So in this case, we're looking at theta, and this symbol down here, theta, is the universal variable for sine, so for angles. We don't know how big it is. It's like x, okay? But we reserve this Greek letter theta to understand or to represent angles of triangles. So notice there's 3 positions in reference to every angle, okay? We never really talk about 90 degrees because that's already understood to be 90 degrees, okay? We're talking about this angle or this angle up here. So from here we have 3 positions. We have the side opposite the angle, we have the side adjacent to the angle, and we have the hypotenuse, which is always opposite the right angle. So this hypotenuse always stays the same. But notice in this example over here, if we're talking about the upper angle, and we may have the exact same triangle, the reference is opposite is now down here, adjacent's next to it, and hypotenuse is obviously still the same. Okay, so when we talk about opposite and adjacent, it's in reference to the angle in question. So let's take a look here at a couple examples. Okay, so here are the 6 different trig functions, and this column over here, let's just kind of go through and talk about what they are. A lot of people want to say, sin. This is sine. Here we have cosine. Here we have tangent. Now this column over here is the reciprocals of these here. So this is basically 1 over sine, and we'll get into that here in a little bit. So let me write that in, 1 over sine. And what we have here is cosecant. Next one is secant, which is 1 over cosine, and a theta. You'll see me a lot of times, I'll do shorthand and I'll forget to put the theta here. That you always need cosine of an angle, okay? So keep that in mind. Then the last one here is cotangent, which is the same thing as 1 over tangent theta, okay? So in this case, what we're going to have is we have several different relationships. These are all ratios, so I'm going to start with fractions for all of them, and we'll talk about what's what. Okay, so in this first case here, sine is always opposite over hypotenuse, okay? Cosine is its brother, which is adjacent over hypotenuse. So notice I'm just using abbreviations, okay? Tangent is the one without the hypotenuse. It's basically opposite over adjacent, okay? Or some people refer to it as sine over cosine. That's another way to look at it, okay? And we'll see that in other examples as well. In the right-hand column over here, these are all reciprocals. So what's cosecant? It's the opposite. It's hypotenuse over opposite. Secant is hypotenuse over adjacent. and cotangent is adjacent over opposite. Okay, so here we have the 6 different ratios of trig for any given triangle, and they're really all related to one another. Okay, and you're going to find that sine and cosine are like two brothers. Tangent is basically relating sine to cosine, these reciprocals. So really, there's only two different ratios, and those are the two right there. Sine and cosine are the two major ones. Everything else is a variation based off sine and cosine. Okay, so let's take a look at some examples with numbers. So notice here I have a right triangle, 5, 12, 13 triangle. And if I want to go through and figure out my relationships, I'm just going to go ahead and start with my fractions, get my ratio set up. And again, we want to do sine is opposite over hypotenuse. So I'm looking at the angle up here. What's opposite? Opposite is down across, which is 5, and the hypotenuse is 13. Okay. So for these values, the sine and cosine, they're always going to be between, in these cases, um, between 0 and 1. Okay, you're not going to have anything bigger than 1, nothing less than 0. Now we get to the unit circle, we'll have negative values and everything else. But for our basic purposes of the simple right triangle, it's always going to be a fraction where the bottom number is the hypotenuse, which is always the biggest number. Hence, 5/13 is the number less than 1. Okay, cosine is adjacent over hypotenuse, so I'm going to put 12 over 13. Okay. Now tangent, once again, is relationship of sine over cosine. So I can simply just take the top two numbers, 5 over 12. Okay, which is basically opposite over adjacent. Okay, so let's just put the opposite over hypotenuse. I'm just going to label them adjacent over hypotenuse, and we can see the relationship there. Now all I'm going to do for secant, cosecant, secant, and cotangent is flip them. This is basically 13 over 5. This one over here is 13 over 12. So notice these are no longer less than 1. It's the reciprocal. So they're also going to be bigger than 1 in this case. And then 12 over 5 for this one. So really today is pretty elementary as far as just understanding the different ratios of what we have. All right, let's take a look at another example. Now, the only thing I did different in this example is notice I had the theta down in this corner. So my point of reference is different. So let's just kind of go through these quickly. Sine is opposite over hypotenuse, so I'm going to say 4/5. The cosine is the opposite one, which is adjacent over hypotenuse, which is 3/5. Tangent is sine over cosine, so 4/5, opposite over adjacent. Then over here, I'm just going to flip them. This is going to be 5 over 4. This one's going to be 5 over 3. And this last one's going to be 3 over 4. Okay, so notice, very simple. Again, I get all my original data from those two right there. I like to get those two knocked out first. Let's take a look here at a couple of different examples. Now, on these, we're going to solve. The reason why we use trig is we can solve for lengths of sides given angles, okay? Because everything is based on a proportion or ratio. So here, notice this is not a 3, 4, 5 triangle or anything like that. All we know is that this is 35 degrees, okay? And obviously the complements on there, but I'm going to focus everything on this, okay? So if I want to solve for A, okay, I know I need this variable, and I'm going to use the other given information, which is 5. Notice I can't use C because it's another variable. I need something that's given. Okay, so I'm going to look, what's the relationship between 35 and 5 and 35 and A? We have opposite over adjacent, which is tan. So tan is equal to opposite over adjacent. So I'm going to fill in my numbers. So let's go ahead and fill in what we have. So we're talking about tan of 35 degrees, okay, is equal to the opposite side is 5, the adjacent side is A, okay. Now, so what we have to do, how do we solve for A? Well, very simply is we just multiply both sides by A. Those cancel each other out. And then the last thing is we divide both sides by tan 35, because I got to get this over here. This tan 35 is a number, okay? So you don't break it up, you just bring the whole thing over. It's just like moving 2, okay? So now we have A is equal to 5 over tan 35. So now I'm going to pull out my calculator, and I'm going to type it in. So let's pull it out here, and use my mouse, turn it on. Again, I'm in radian or degree mode, so you can see that there. And I'm just going to type in 5 divided by, and again, I always like to use parentheses, so I'm telling the calculator what to look for. And I'm going to type in tan of 35. Okay, and hit enter, and this length over here of A is 7.14. So A is 7.14, thereabouts. And obviously the decimal went on, but let's just go 2 decimal places for approximate answer, and that should be good enough for now. To solve for B, okay, actually we don't have the B here, so let's change this to C. Change my variables. Let's solve for C. So C is, use a different color here. C is hypotenuse, and I'm going to look at opposite. So opposite of hypotenuse is sine. So I'm going to say sine of 35 is equal to opposite over hypotenuse. The opposite is 5. The hypotenuse is C. And again, I'm going to do the same setup. I'm going to move the C to the top side, and then I'm going to divide by the sine 35. That's just basic algebra there. Flips in those spots. Some people think about it's like cross multiplication. You could switch to C and a 35 interchangeably, and nothing changes. Okay. So again, I'm going to go back to my calculator. I'm going to move it over so we can see the problem, and we're going to have 5 divided by parentheses sine 35 close parentheses and hit enter. Okay, it's not necessary to throw those parentheses all the time. I like to, just because there's no error there in what's on the bottom, what's on the top. So we have 8.72 by rounding it. So 8.72. So let's go ahead and fill that out. 8.72. Okay, so notice this is hypotenuse, so this should be the biggest side, which makes sense. A should be smaller than 8.2 because it's hypotenuse is always the biggest. So that's how we use trig to solve for sides. Okay, so that's really about it. So I'm going to have you guys start on a homework here. I'll have the we'll scroll to the next slide on the smartboard lesson, and you guys can get started on the homework here in class.